Okay, so we're in a very specific type of math today. We're looking at pH levels and logarithmic functions. So we've gone over logarithmic functions, and this is how a logarithmic function is related to a normal exponential function, and we're going to use this relationship to essentially evaluate. Now, they've given us a question that deals with pH levels, and they've given us an equation. The pH level is equal to a negative log times, or the value of the log, because I guess it's log 10 in this case, is a hydrogen plus, and that stands for the concentration of hydrogen ions in moles per liter. So the very first question, oh shoot, grab that page. What page is it?
No,
I think it had to do with
this.
Okay. The calculate the pH if the concentration of hydrogen ions. Okay. So our concentration of hydrogen ions is 0.001 moles per liter. Okay. So this is definitely in base 10. So the very first thing we want to do is actually make this value in an elementary school, they use like a scientific mode on a calculator, but we want to put this in a base 10. Okay, so do you know how we could put this to base 10?
Base 10?
Yeah, in other words, I want to convert this so that it's a exponent of to the power of 10 of some exponent. So 10 to the power of something is equal to 0.001. Okay, so we need to look kind of into that question here. 0.001. Do you know how we go about that? Well, we can do this by putting this actual value into our hydrogen here. What we'll do is actually replace that because we know that's in moles per liter. And what we'll do is we'll figure out that our pH is equal to the negative log of, and in this case, 0.001 10, right? Because we know this is log base 10, right? Well, let's use our little relationship that we have here. Our pH is essentially going to be our A value in this case. Our base 10 would be the same as our base in our exponent, okay? So if we have negative log 10, 0.001, that's also the same as writing, or it's the equivalent of writing, because we got to find out what A is equal to in this case. That's what our pH level is going to be. It's the equivalent of writing as an exponent base 10, A being our unknown, is equal to 0.001. Okay, so we go about trying to calculate this in this question. So we need 10 to become this variable. So I need to make this a base of 10. Well, just to give you a hint, 10 to the power of negative 1 is the equivalent of 1 over 10. And do you know what 1 over 10 is equal to? 0.1. So as our exponent increases, we get more zeros in front of our 1 value. So in other words, because we actually need this value to be 10 in this case, we need to move this decimal, and the amount we move this decimal will tell us how far we need to move the exponent. So we need to move it 1, 2, 3, 4 spots. And because it's going back to the left 4 spots, it's going to be, in this case, 10 to the power of negative 4 is equal to 0.001. Okay? So that gives us our negative 4. But let's go back to this original formula. All that really solves is this part here. Okay? We know that that there is equal to negative 4. That's what our A value is going to be. So our pH, in this case, is equal to negative. And since our A value was negative 4, negative 4. Well, in that case, that ends up giving us a pH level, because there's 2 negatives, of just the number 4. Okay? So what we do at the very end, we incorporate this negative on the outside. So we evaluate the log the same way we had evaluated them before. You might be able to even put that in your calculator if you have log base 10. Do you? You might want to try that. But that's how we would do it without a calculator, calculating that pH level. Let me stop that time. Let's let's maybe jump to a second question here with pH levels. So another question says the pH of lemon juice is 2. So pH is equal to 2. What is the hydrogen ion concentration? In other words, what are our moles per liter in this question? Our moles per liter in this question. So our moles per liter. Okay. So if pH is 2, our formula states that pH is equal to the negative log base 10 of our hydrogen plus. And that's pretty much what we're looking for in this question. Our hydrogen plus, that's our unknown. We have pH. pH in this case is 2. 2 is equal to negative log 10. Okay. Now there's a couple ways we're going to do this. First thing we want to do, and because our H pluses are unknown, let's move this negative value. Think of it like it's being multiplied by a power of negative, or so the value of negative 1. Let's move that negative to the other side. When I move it to the other side, what will happen?
It's going to become positive.
The right side will, but what will happen to the left side?
When you move that over?
Yeah, so if I divide both sides by negative 1,
it'll become negative.
Yeah, so we get negative 2 is equal to log base 10 of H plus, let's say. Well, we know in terms of logs, what that really means is we have log 10, and we'll call this value in this case, what do we normally call it? That was our y value. So we'll say of y is equal to negative 2. Well, we know that the equivalent in exponents is 10 to the power of negative 2 is equal to y. Well, this is very simple for us to calculate. We can calculate 10 to the power of negative 2. We know that what that's going to be, in this case, it will make the exponent positive, becomes 1 over 10 to the power of 2 is equal to y. 10 to the power of 2 is 100, so 1 over 100 equals y. 1 over 100 as a decimal is 0.01. Okay? So in other words, when we go to plug this all back in, our H plus here, we know that our H plus, or our hydrogen concentration, is equal to 0.01 in this case.
Right.
Does that all make sense?
I'm not really sure. Here, like the middle of the page where it's log 10y, yeah, that.
Yeah.
And then why did you go to 10 to the power of negative 2?
Oh, okay, because this was our equivalencies. If you remember, we usually write it as log x, y equals a, and we equivalent in an exponent form would be x to the power of a is equal to y. Okay? So what we did is here's our x, right? So my x happened to be 10, so my base happens to be 10. Y in the exponent becomes the answer. Well, in this one, y was unknown in both. And our a value, okay, becomes the exponent. Well, our a value was negative 2, so that became the exponent in our exponential function. And then we worked it out that way to figure it out. So we converted back to an exponential function in order to figure out what our log was going to be equal to. Okay, so that would be, so that's everything we've done with pH there. Could technically be less, but this will be good. Okay, hardest question here. If the hydrogen ion concentration, so that's our H plus, is a measure of the strength of an acid, how much stronger is an acid with a pH of 1.6 than an acid with a pH of 2.5? Okay, so we're going to have two formulas, and we're going to be plugging them in here. And in both formulas, we do know what the pH values are. Okay, and we just want to keep in mind our equivalent formulas of logs and exponential functions. Okay, so in the first one, pH is 1.6, so that means 1.6, that's our pH, is equal to negative log 10, and we're looking for our H plus, which is exactly what we just did in the previous question. And the other one, 2.5, is equal to our negative log base 10 of H plus, right? Very first thing we did in the last question was move these negatives over. So we're going to move them over in both of our examples. We have negative 1.6 is equal to log 10 h plus. And in this one, negative 2.5 is equal to log 10 h plus. Great. Now what we're going to do is write these logs in their exponential forms. Okay. So this gives us the base. So as an exponent, we get 10. I can't see that. Never mind. 10. Our a, which is our in log, our answer becomes our exponent. So 10 to the negative 1.6 is equal to our y, right? And our y in this one happens to be our h plus. And that's what we're trying to figure out, right? So that's our first one. And our second one will become 10 to the power of negative 2.5 is equal to h plus. So we find out what these are actually equal to. In this case, 10 to the power of 1.6 negative 0.2511. So this is 0.25. I think I read that wrong. I think it's 0.0. Yeah, 0.025. So 0.025. Did you calculate the other one by chance?
Nope. It's
right.
10 to the power of negative 2.5.
Yeah.
0.00316.
Excellent. Okay, so we've calculated their acidity levels, I suppose you'd say. And they want to know how much stronger one is than the other. Well, this one here on the left is our larger value. Okay, the one on the right is a smaller value. So we're trying to figure out how much stronger something is, how many times stronger. We're going to divide the larger number by the smaller number. Okay, that gives us a measure of how much stronger something is. So we take our 0.02511 divided by 0.00316, and that is equal to, we should get a whole number. $7.946. Okay. Now they got a roughly, we'll say approximately, because I think they got about 7.8. So we had a bit of rounding in our question. We rounded where they probably didn't. But that is the way that we figure out how much stronger something is than the other. Okay? We calculate their two h's and then just divide the two. So in other words, I would need to multiply this by 7.9 or 7.8, let's say, to get this value. And that's what we're going to figure out.